December 1972. Commander Gene Cernan shakes the gray dust off his boots and climbs the ladder of the lunar module Challenger. His last words echoed a promise. "We will return." The engine ignited, the spacecraft descended, and silence fell over the Taurus-Littrow Valley. That silence lasted half a century. For 50 years, the moon remained there, a silver witness orbiting our hesitation. An entire generation was born, lived, and aged looking at the sky, wondering why we stopped. Why did we abandon the frontier? But the time of waiting is over. Behind the scenes, away from the spotlight, a new architecture has been designed. We are not just going back to plant a flag and take pictures. The era of tourist visits is over. This time, we are coming back to stay. This is the Artemis program. Named after Apollo's twin sister in Greek mythology, the goddess of the moon and hunting, it is the most complex, dangerous, and ambitious engineering project ever conceived by our species. Unlike Apollo, which was a political race born from the Cold War, Artemis is a sustainable expansion of humanity. To accomplish this titanic task, we needed a new giant, a machine capable of overcoming Earth's gravity with brute force. Let's contemplate the SLS. Space Launch System. A colossus 98 meters tall, taller than the Statue of Liberty. It is the only operational rocket in the world capable of sending humans, habitats, and massive cargo into deep space in a single launch. At the heart of this engineering, 4 RS-25 engines roar. They are veterans, rescued and enhanced from the Space Shuttle program. They are the most efficient thermodynamic machines ever built, consuming liquid hydrogen at 250 degrees below zero. But they are not alone. 2 solid rocket boosters provide 75% of the initial thrust. Once they ignite, they cannot be turned off. They burn 6 tons of fuel per second, generating the controlled violence necessary to escape the atmosphere. The result is a force of 39 meganewtons. That is more power than 160,000 Formula One engines accelerating at the same time. The ground shakes kilometers away when humanity decides to leave the planet. At the top of this fire spear, protected from the acoustic hell, travels the Orion ship, our new vessel for the cosmic ocean. It is the safest and most advanced spacecraft ever built for human transport. The Orion is 30% larger than the old Apollo capsule. It is a technological refuge designed to keep 4 astronauts alive for up to 21 days in deep space, managing every molecule of oxygen and every drop of water. It is powered by the European Service Module, proof that Artemis is a global effort. This module provides electricity through solar panels, propulsion, thermal control, and the vital consumables for the crew. The Artemis 1 mission has already proven the capability of Orion. It flew farther than any spacecraft designed for humans has ever gone, orbiting the moon in a distant, retrograde trajectory, breaking records and testing limits. And the final test, the return. When colliding with the Earth's atmosphere at 40,000 kilometers per hour, the thermal shield faces temperatures of 2,700 degrees Celsius, half the heat of the sun's surface, protecting the fragile life inside. But our landing strategy has changed radically. We will not fly directly to the surface. First, we will build a safe harbor in the sky, the Gateway Space Station. The Gateway will be humanity's first space station orbiting another celestial body. It does not rotate in a simple circle, but in a nearly straight halo orbit, known as NRHO. This orbit is a masterpiece of celestial mechanics. It is an unstable but efficient balance point that allows for uninterrupted communication with Earth and easy access to any location on the lunar surface, including the poles. There, the astronauts will live in the Halo module, a compact, pressurized habitat. It will be a laboratory, a dormitory, and a command center floating thousands of kilometers from the lunar surface. A gateway functions as a transfer point. The Orion is the taxi that takes the crew from Earth to the station. But the Orion doesn't have legs to land on the moon. To descend, we need a completely different spacecraft. For the landing task, NASA went all in. It chose SpaceX's Starship HLS. It's not just a landing module, it's a stainless steel monster, the largest flying vehicle in history. Compare it to Apollo. The old lunar module looked like a fragile aluminum spider where two men barely fit standing. The Starship is a 15-story building, with a habitable volume larger than that of a large house. The logistics to take this giant to the moon are insane and revolutionary. The Starship is so heavy that when launched from Earth's orbit, it uses almost all of its fuel just to ascend. The solution is orbital refueling. Before going to the moon, the Starship parks in Earth's orbit and receives multiple space tankers. It's a delicate dance of transferring cryogenic methane and oxygen in the vacuum. With the tanks full, she travels empty to the gateway. There she waits like a transatlantic ship in port. When the Orion arrives with the crew, the astronauts float into the Starship for the final stage. The descent begins. 2 astronauts on board. The destination is not the safe gray plains of the equator where Armstrong walked. The target now is the forbidden and treacherous terrain of the lunar South Pole. The South Pole is an alien world within the moon itself. The sun here never rises high. It rotates on the horizon, creating shadows that stretch for miles. It is a land of brutal contrasts between blinding light and absolute darkness. The Starship does not use its main engines for the final touchdown to avoid digging a huge crater. It activates upper thrusters. The steel giant descends smoothly, balanced by autonomous computers. There is no short ladder. The cabin is so high that astronauts need a mechanical lift to descend 30 meters to the ground. The descent is slow, allowing time to contemplate the magnificent desolation. So, it happens. The moment that will go down in history. The first woman and the first black person to leave their footprints in another world. The return of humanity, not as conquerors, but as resident explorers. They wear the new suits from Axiom Space. Forget the rigid suits of Apollo. These are flexible armor, with bearings at the joints, allowing them to walk, kneel, and work like real geologists. Why did we choose the South Pole? Because of what is hidden in the shadows. The permanently shadowed regions. Deep craters where sunlight hasn't entered for billions of years. In these icy abysses, the temperature drops to 230 degrees below zero. And there, mixed with the soil, is the most valuable resource of the solar system for our survival: water. Billions of tons of ancient water ice, brought by comets ages ago. Water is not just for drinking. Chemically, water is hydrogen and oxygen. If we break the water molecule with electricity, we have oxygen to breathe. But the most important thing, liquid hydrogen and liquid oxygen are the most powerful rocket fuels that exist. The moon will become our gas station in space. This changes everything. We will no longer need to carry all the fuel from Earth, fighting against heavy gravity. We can refuel up there. The Artemis 3 mission is just the beginning of the campaign. Artemis 4 will expand the gateway with the International Habitation Module, the IHAB, solidifying human presence. On the surface, exploration will gain wheels. The LTV, Lunar Terrain Vehicle, will arrive. And then, the pressurized rover. Think of it as a high-tech space trailer. Inside it, astronauts can take off their suits, sleep, and eat, traveling for weeks and covering hundreds of kilometers, doing real science far from the landing base. The long-term plan is the Artemis base. We will not bring bricks from Earth. Autonomous robots will use lunar regolith, the dust from the ground, to 3D print roads, landing pads, and radiation shields. Solar panel towers will be installed at the peaks of eternal light, crater edges that receive sunlight almost all the time, ensuring a stable power grid for the colony. And to face the lunar night, which lasts 14 Earth days of absolute cold, small fission nuclear reactors will ensure that the lights and heating never fail. But don't be fooled. The moon is a hostile and deadly environment. Lunar dust is not like beach sand. It consists of microscopic shards of volcanic glass that destroy seals, tear fabrics, and, if inhaled, can destroy the lungs. Cosmic radiation is another invisible enemy. Without an atmosphere and without a magnetic field, astronauts are exposed. The base will need to be buried or covered by meters of lunar soil for protection. A violent solar storm can happen at any moment. The alert systems will have to be infallible, forcing the crew to run to armored shelters in minutes. The margin for error is zero. NASA is not doing this alone. The CLIPS program is already contracting private companies to deliver payloads. The future of the moon includes mining robots, telescopes, and commercial laboratories. We are creating a cislunar economy. A network of GPS and internet satellites called LunaNet is already being designed. Soon, there will be high-speed Wi-Fi on the lunar surface. Exotic resources such as helium-3, rare earth metals, and titanium could one day sustain entire industries, transforming the moon from a geological museum into an economic engine. But the question many ask is, why spend billions on the moon? The answer shines red in the sky: Mars. The moon is the school where we will learn to live away from Earth. Mars is 6 months away at best. If a critical system fails there, you die. On the moon, you are only 3 days away from rescue. It is the perfect place to fail, fix, and learn. Let's test how the human body withstands partial gravity for long periods. Let's perfect the recycling of air and water until we achieve a total closed loop where nothing is wasted. If we can survive on the moon, using local resources to sustain ourselves, we will be ready to take the big leap. The moon is not the end of the line. It is the springboard to the rest of the solar system. The pioneers already have faces. The crew of Artemis 2. Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. They will be the first humans to see the far side of the moon with their own eyes in over 50 years. They are training now, submerged in giant pools, locked in simulators, flying combat jets. They carry on their shoulders the weight and hopes of 8 billion dreamers. Imagine the moment of the launch. The world will stop again. Big screens in Times Square, Tokyo, and Rio de Janeiro. Humanity, for a brief moment, united by awe and audacity. The technology we are developing is vital. Systems that recycle 98% of urine and sweat into pure drinking water. Technologies that will even help solve water scarcity problems here on Earth. Communication will be revolutionized. The Deep Space Network is being upgraded with optical lasers capable of transmitting 4K video from the lunar surface in real time. You will see the exploration as if you were there. We are mastering cryogenics in space, learning to keep ultra-cold liquid fuels for months, a key technology for future nuclear ships that will take us even further. Artemis is, above all, a diplomatic effort. The Artemis Accords establish rules of peace, transparency, and cooperation. It is an attempt to bring the best of humanity to space, not our conflicts. But geopolitics exists. China is planning its own lunar research base, the ILRS, for the 2030s. A new space race is happening, and competition has historically been the greatest fuel for rapid innovation. The schedule is set. Artemis 3, 4, 5. Every 2 years, a new launch. A constant and growing presence. We will cease to be visitors and become permanent residents. Soon, we will see the first green leaf grow in lunar gravity. And perhaps, still in this century, the first human baby born outside Earth will look at our blue planet in the sky and call it Grandpa. The view of Earth from the South Pole is mesmerizing. It never sets and never rises. It simply rotates on the horizon, a blue and white marble suspended in the darkness, constantly reminding us of where we came from and what we must protect. We are the privileged generation that will see humanity become a multi-planetary species. This is no longer science fiction from old books. It's in the congressional budget. It's on the assembly lines. It's happening now. The fire has already been lit. The hardware is being bent, soldered, and tested in the factories of New Orleans, Florida, and Texas. The dream is turning into metal and fuel. The return is not just a desire. It is a manifest destiny of our curiosity. It is proof that despite all our problems, we are still capable of greatness. Look at the moon tonight. It is no longer just a cold rock in the night sky. It is our 8th continent, waiting to be populated. We are coming back to rediscover what it means to be human. To explore, to overcome the impossible, to extend the light of consciousness beyond our home atmosphere. Subscribe to the channel to follow this journey. Until next time.